Thank you for attending to today's presentation. My name is Tayen Aguilar. I am a solutions engineer focusing on the architecture, engineering, and construction um, industry for Altair Engineering. And today we will talk about how to design steel structures according to the Eurocode 3, specifically the Spanish Annex. So, in the next couple of minutes, we will discuss how to uh, analyze and design steel structure using this code. Please bear in mind that these particular design codes are relative to some of the newest iterations of S-Frames software, which it starts with 2024.1. So you will need these or newer versions in order to do it. I'm really sorry. My throat is not the best form today. But well, let's begin by talking about what steel structure design means in Altair, in the AEC, in the S-frame suite. With S-steel, or also called the steel design model, you can code check and design an entire steel structure by using S-frames capacities of modeling and analyzing. Once that you've done that, you can code check section by section and verify that your design is on the best form. Like I briefly mentioned, it has a seamless integration with S-frame. So you can model your full structure in S-frame, add different sections, analyze this structure, and within the same environment, within the same user interface, you can code check and design these elements, this full structure, obtaining utilization radios and getting code detailings and very good reports of this. All of this is sustained within different international design codes. So this workflow with minor adjustments depending for each code can be made within many different international design codes. We will talk in a minute about the different design codes that are supported in S-Frame's steel design. And also, like I briefly mentioned, we have some automatic engineering design reports that are generated for each one of the members with each one of the sections that are being used or compared, which you can take a look and see the detail in each one of them with each one of the classes. These engineering reports are very powerful and are the main reason why many users come to S-frame and S-steel applications. Like I was mentioning, these engineering design reports are a very important part of the workflow because this is why, at the end of the day, structural engineers need the software because we need to have access to a report that is efficient and that can be shown to clients and to colleagues, where we can show the work that we have been doing. We are very well known in these engineering design reports because they are very easy to generate. You can do it with just one click. They are very detailed, and of course, they are transparent. All of the information it's going to be included into the design reports. So Um, very powerful, very easy to use. Now, here we have some of the supported steel design codes in the latest versions of SRAM, which is 2025.1, as the speaking of today. And as you can see, we have a very comprehensive view of many of these codes. Note that, for example, the US, the Canada, and the Eurocodes, we have different iterations for each one of them. So, for example, in the case of the US, we have codes for different methodologies and different versions. The same applies for Canada, and of course, the Eurocodes or the EC3 also has different national annexes, which is what we will focus on today. For the Eurocode 3, for steel design, we have support for the UK Annex or the British standards as well. And we have the Singapore Annex and the three national annexes of Germany, France, and Spain. From there on, we can see the rest of the offer from Australia, New Zealand, Hong Kong, China, and even special structures for offshore platforms and lattice transmission structures. So, in today's quick chat, we will talk about this workflow that allows us to analyze and design a structure. The first step is to run structural analysis on our model to visualize the results that we have. Then we're going to switch to the steel design module to code check different sections to obtain the utilization ratios and take a look at the reports to see if they are passing or not the different code checks that we are exposing them to. Then for after doing this, we can define new sections for study by grouping the different sections that we have, or even by member type. So we have beams and columns, or beams and trusses. We can do that, which really helps streamline the design. Then we can re-execute the code check to apply a design. This time we can efficiently select each sections, take a look at the detail reports, and see what is passing and what is not passing the different code checks. After we have selected the new sections, we can update them into our model and reanalyze them in SRAM. So with that said, let's switch into S-frames. And now, here we have a crane tower that was built with the purpose of explaining and illustrating different wind load generations for the Eurocode 3 steel structure. So let's make a quick rundown of this model. Let me show you that I have selected here different sections for the different types of members. I have sections for the vertical members, another one for the trusses, another one for the tube sections. Then I have other type of sections here on the small tube that are having here the counterweight, right? All of this has been applied to steel from the EC3, from the Eurocode 3, to comply with the regulations. This is by default one of S-frames available materials, right? So let's see, this is what it looks like in the rendered model. We have sections here, and we have smaller sections for the crane itself. The tower has a different kind of sections. Then let's also take a look at the different loads that we have. Apart from the soft weight, wind load was added, which we can see if we apply the member loads. And like I mentioned earlier, these wind loads were generated or calculated to match that of the Eurocode 3 wind load conditions. We don't have much else in this model because it's made to illustrate one specific design purpose. So once that we have an idea of what the model looks like, we can go ahead and run an analysis. We're just going to run a linear static analysis, click on OK, and then we're going to have some clean analysis. The only thing that is telling us is about these four members in the top, which were cable type, but were converted to truss. That is because we don't need right now a nonlinear analysis, which is necessary to analyze cables. We're not going to do that at the moment. We're just going to focus on the different vertical trusses, tubes that we have here. We're going to leave our cables out of this design exercise. So once that we have done that, we can take a look at the different results of the analysis. For example, we have here the self weight. We can see that with the self weight, our structure tends to deflect like this. And if we consider the wind action, it's going to rotate like this due to the wind action. We can also take a look at the reactions and our axle and moment and shear diagrams over here. If we want to take a closer look, for example, at the base members over here, we can select one of those members and click here on properties. Here we can visualize the results that we have for the different load cases, the wind and the soft weight, and we can take a look at the different types of diagrams like the axial, the shears, the torsions, because in this case we have some, and the moments, right? We can also, and this applies to each and every one of the members. So if we apply this to a different member, or we can see the information regarding that specific member. We can also click here on multiple diagrams and visualize the different results, a summary of all the different results in that particular member. So for member 14, we can see here our deflections, and then we have the local forces in shear, in torsion, in moment, at the different stages, and then we have the diagrams over here. This is for the soft weight, etc. So we can look closely into each one of these members' forces, right? So after we've done that and we have seen that our analysis is correct, we can switch into the steel design model just by clicking here on Run, Steel. Then we can go here into our code input, and here we have a few options. We can select the full structure, or we can focus only on the different sections that we want to code check. So for this structure, I'm going to go with the full structure. I'm going to code check the full structure. I just want to make sure that I am using the correct design code. So I can go here to options, then click on design code, and I can select from here the steel database that I am using. As you can see, as I designed this for the Eurocode 3, I already have selected European, but if I were to switch to any different one, I would need to make the necessary adjustment. I just wanted to show you here the different options that are available. I'm going to stick with European, but Considering the steel database, then I can also select my design code. I have selected the Eurocode 3005 for Spanish Annex, but over here we have German, French, the Korean, and the Canadian, etc. So you can switch that directly from here if you didn't select it in the modeling phase. You can also specify the partial resistance factors. That it's basically the interaction between the actual and moment forces. By default, Spanish Annex uses method number one, recording to clause 6.3.3. But if you want to specify a different resistance factor, you can do it from here. So I can click here on OK. Once that I see that that's according to what I want, then I can click on Run, code check, and then I just select the load cases that I want to code check against. So I click here on OK, and then I will get the utilization radios for all the different members that I have in here. So right now, this might look like a lot of information, but you can basically see that we have a lot of members that are colored in red, which means that the utilization is higher than one, right? So if, for example, we go to the level one, we can see here, if we select this window, that we have most of the trust members failing. We have a very big failing member in these two, 17 and 43.9. If we go to the second level up here, we can see that we have a similar situation. So we can see that these trust members are definitely not a good match for what we want. We can see, for example, that the vertical members are a much better fit to what we have, except for the base members that are in a much critical condition. But what happens is that with these trusses, all of these trusses are basically failing. We have very few that have a decent utilization rating. So we can just take a look at one of these. Let's take, for example, this one that has a 17.9 utilization ratio and go to the code details. This is a detailed report of that member for that particular section. So we have here 50 by 50 by 4 EA section, which is basically this channel type. And we have the detailed report for the load case 1 and the load case 2, which is causing all of these issues. This is a section 4 class, and it's basically too much of a slender section. Our compression check, it's failing by more than 10, so it's a critical fail. We cannot use this into a design. So if we wanted to do that for each one of the sections that are present here, we could do it just by the sake of it. Let's take a passing section, go to force details, and take a different look at it. We can see that it's the same section, 50 by 50, but in this case, that particular member, it's passing with a utilization ratio of 60% or so. So now that we've seen the different utilization ratios for each, what we can do is execute a different design with these members only. Let's focus on the trusses. What we can do is go here into a defined sections to study, and it's going to trigger this warning that says that not all of the members of a group are selected. So what it basically means is that I have selected only this group, and it's going to execute only changes into this group. That's exactly what I want. But the program always warns you about it, always tells you about it. So here I can select from the different section shapes. And I want these EA types still to be the factor form that it's going to be in the sections. But if I were to select any specific type of angles, I can select and deselect them directly from here. If I want to look at the specific section properties of it, I can do it as well from here. I can specify minimum and maximum for each one of them. I can sort them through different criteria like weight and cost and surface area, etc. So for this case, I am just going to focus on the EA types, on the channel types to see what applies and what doesn't. So I'm going to click here on OK, and then I'm going to run a design. I'm going to select both load cases. I know that wind is a critical, but I can do for both. Now, what it just did is that it compared all of the different sections that I told it to with the different load cases and got me the utilization radios for them. So as you can see, if you remember, we have these truss members over here with a utilization of over 17%, which is of course not ideal. But now we have them here with a much better utilization ratio. So we can see here what the original section was. The S-frame section was 50 by 54. And now the new proposed section is 50 by 5. And all of these are the admissible sections. So the list in here, it's all of the sections that are passing code checks. And over here, we have all of the sections that are not passing a code check. So as you can see, we were quite close when it comes to the naming. And we can take a look at the code details over here. We go here to Zoom, and we can see that this is the same detailed report, but now it's passing all of the code checks. So we can take a closer look at one of the members that was failing much worse. If we go here to our force diagrams, we can see the different diagrams that are affecting this particular member. And we can see the detailed reports for that one as well. So once that we have changed to a different section here on the trusses, in general, these sections can be applied for the worst case scenario, like in here, which is a little bigger section, and take it back into our S-frame modeling. If we click here on build analysis model, it's going to ask me, do you want to overlay the S-frame model with the new proposed sections? I can tell it to say yes. Now I can just say here, save it as the tower crane. And I'm going to replace it. And now I have my new sections assigned to the truss types. And I can rerun an analysis one more time just to make sure that the different actions of the sections, the resistance, etc., has been applied. We can verify this over here with these new section types. I remember that we have some issues when it comes to the moments over here, and now all of them are having much less stress. So that is the general idea on how to work your way through a steel design using Eurocode 3. Remember that this structure was modeled having the wind resistance factors and the wind loads for a tower crane applied. But of course, this is for illustrative purposes. In real design, we would have to also consider Eurocode 3-6 for tower crane design with a specific resistance factors for torsions, etc. So this is for illustrative purposes, but I think that it illustrates pretty well what we wanted to showcase. Now, let's open the floor for some questions, and let's see if we have any. Okay, so we have here one question that it says, which national annexes are supported for Eurocode 3? So that's a good question. Thank you. So we are currently expanding, and the latest Eurocode national annexes that are supported are Spain, which is what we showcased here, Germany, and France. But we also have support for standard Eurocode 3 for the UK Annex, which is different to the British standards, and the Singapore Annex. Yes. Okay. Yeah. We have another question here. It says, um, does the sections automatically update to the different member types? Um, thank you. So the sections will automatically update only if you tell the software to do so. If you click on yes when you are grouping your elements, it will automatically update them. But you can just run an analysis if you want to and go back into your design and select different sections and apply different sections to different member types, or assign them to critical members. So it's not definitive once that you have new sections. That's why it says it's a proposed section. You can do it, but it's of course up to you entirely. Okay, we have one. We have time for one last question before we get into it. And this last question says, okay, so probably we're going to have to end it here. We are already over the allotted time, but thank you very much for your time. Thank you very much for your spending your time in this quick lesson. If you have any additional questions, please do send them along, share it to them into our inbox. We will be very, very happy to help you solve any of those questions. So thank you very much for your attendance. Have an excellent rest of the day. Thank you.